Good evening. Yeah, as you can see, motorcycle awareness jacket is thought of it because I wanted to make something that, okay, I wanted to make something that was easy to use and it was also safe because one of the things that I've noticed is that a lot of the older riders know what the hand signals are, but the new ones don't. So I wanted to have something that could sort of put that in a way that the average person would see it. Another thing I noticed that as bikes get newer, the turn signals get smaller. So I wanted to make them a little bit bigger and also elevate them on the jacket as well. So those are the basic signals, and that's what I'm going to demonstrate a little bit later on the jacket. So other people have tried to do this before, but they've always tried to connect it to the motorcycle. And I think that's a bad idea because you don't want to have somebody trying to hook up something, trying to wire something, but that costs money. And I wanted to make something that was cheap that you could just put on, turn on, and ride off with it. Right, so what I did, have an analog sensor on the elbow, and I have two digital sensors, one on top of the shoulder, one on the back of the shoulder, so that when your hand's in this position, you can go left or right, but as soon as it moves away, the circuit opens and the lights go off. Here's a quick video of what I'm trying to avoid.
Most bicyclists fear getting run over from behind. For good reason, rear-end collisions are more deadly.
Okay, that's not the right video, but you get the point. Trying to avoid rear-end collisions. Alright, that's my circuit. So basically, I use a small 12-volt battery. I think it's 1.3 ampere hours. It's connected to the Arduino with a simple switch on or off. Okay, that's my shoulder switch for the top of the shoulder. That's the switch for the back of the shoulder. I have a 10K ohm resistor. And then I have my flex sensor, which is grounded. And then that flex sensor goes back into the Arduino. And then from there, I've got my three lights, my left turn, my proximity light, and my right turn. Now, of course, this is what it looks like on paper. And this is what it looks like in real life. And that has to somehow go in the jacket. So this was the point where I started to think maybe I should have had a partner, but deal with it. All right, so first thing I had to do, that's actually the plug for the Arduino, and I use an Arduino Uno. So I desolder that, through hole desolder it to get the plug. That way I could take it from where it is on the left, where it is on the right with my switch, and of course all that goes in the jacket. All right, and I have a short video, but I also have it here, so I can demonstrate it here as well. This is right here. And those are my shoulder sensors, circuit's open. Right now, I'm going to close it, and it should be in the left turn position where the arm is straight and blinking. And I'm going to move it to the right position, which will be 90 degrees. There it is. And back to left. Back to right again. And there's a little bit of a problem with the proximity light, which is that light in the middle. I'm gonna have to check the wiring. I may have to rewire that because it is blinking, but it's blinking so fast you really can't see it. So I need to slow that down. And those, of course, are the shoulder sensors that are gonna be in the jacket. Alright, now I did run into a small problem, but it's not really a problem, it's just a learning opportunity. So when I put that flex sensor on the back of the elbow, when I move, it doesn't move because I kind of move inside the jacket. So I tried to put it on the inside. When I put it on the inside, it moves too much. So every little move that I make, it gives me a different value, and that throws off the Arduino and it's not consistent enough for me to say when I have this value, output this light, when I have this value, output this light. Another thing I tried, and I think my professor here is gonna like this, 3 rings, 1 ring on the forearm, 1 at the elbow, 1 on the bicep, but of course, I run into the same problem I did in the previous slide. As soon as I move it out of that cylindricity tolerance zone, the readings go off the chart and it's not usable. So I'm still looking for a solution to that right now. What I may have to do is kind of do what they do in the video games when they're put sensors on the person and have them run. I'm gonna have to do something like that. Of course, that's gonna cost more money, but I'll figure it out somehow. So, any questions?
What was the hardest thing to package? Battery, controller?
The programming was the hardest. The controller, I just had to put it in a place where it wouldn't move too much, but I still needed it to move a little bit. So if there's a shock, it doesn't just absorb the brunt of the impact. The battery, I just stuck it in the pocket and put a switch in series with the positive.
First of all, glad I appreciate it. It's been a chance to backup, especially traffic. How big was that battery? 12 volt battery?
It's 12 volt, I think it's 1.3 amp hours. I have it.
You have to use that big side battery.
Yeah, it draws a decent amount. Calculation is only lasts for about an hour. It's 1.3 amp hours. But of course, I didn't want to do too low because it's very well. I wanted that battery life. I don't know if everybody can see it. There's your straight edge of that, and you go right. Right. Turn that off.
Yeah, question for you. So have you, I can't see it because I'm a little bit too far back.
Mm-hmm.
Have you actually worn it out on the road, and what reaction have people around you had?
I wore it and it was stuck in the left turn signal. Of course, most people don't turn their signal off anyway, so I just kind of Yeah.
You thought about maybe putting it farther up on the wrist or something?
Yeah, I'm thinking about that too. Move it up a little bit, see how it goes. Mm-hmm. That's another idea too. I can hook up another Arduino to the bike. Right. That's an idea too.
Think about maybe putting a sensor up so that it's easier to control control.
Right, I thought about that too, because I was thinking about, it has to be tight, so that as soon as I move, it moves, so that's also a good idea too. I don't have hazard yet, but I can wire that somehow. I have to do that on a switch somehow, because there's no signal for hazard, but I can put that on a switch.